Hello, this is our last lesson on geometry. Now, what we're going to look at today are polygons, and polygons, the word poly, or the prefix poly, refers to many, and so polygons is a very, very broad word that means basically many-gon, meaning sides. So many-sided shapes. So really, we've done triangles, we've done quadrilaterals. Now we're doing everything that's more than that. So 5 right through to as many as we want to go. So we see here, sorry about the lag, pentagon means 5 sides, hexagon 6, heptagon, octagon, nonagon, decagon, undecagon, dodecagon, and the list goes on. This is actually a standard nomenclature, in other words, a standard name that or a set of names that, prefixes that we give to all of our mathematical shapes and some other things. For example, in the periodic table, you'll see these as well. So you can actually look up, if you want to figure out a 67-sided shape, you can look that up on Google and figure that out. But the bit here, in the same as when we did our quadrilaterals, we're looking at convex polygons and non-convex polygons. So a convex polygon is where all of the sides point outwards, where a non-convex polygon is when you have angles that go inward, in other words, that are concave. But rather than saying concave polygon, we call it a non-convex. And you see, unlike quadrilaterals, you can have more than one concave angle within it. If you want to look that up, you can just pause and keep on going. Now, what really do we get asked about polygons? Well, we get asked 3 things. The first is the angle sum of a polygon. In other words, what do the angles all add up to? Now, you can use this formula, which is 180 brackets n minus 2 brackets degrees, where n is the number of sides of your polygon. 1, 2, 3, 4, 5. So in this case, we would say A is, or should I say the number of degrees is 180 times n minus 2, so 1, 2, 3, 4, 5, we established before. 5 minus 2, so it's 180 times by 3, which is 540 degrees. I cheat. Do you want to show you how I do it? I often tell my kids who don't like formulae to try to start at one corner and try to make as many triangles as you can. So we can't go out there, we'll go out to this one, that's one triangle. We go out to this one, that's another triangle. And we know that each triangle adds up to 180 degrees. So what's 3 lots of 180? Well, it equals 540 degrees. And that's basically the way that I do it. However, the formula is much neater and much more elegant. So if you're good at remembering formulae, then do that. The next thing that we get asked is the size of each angle in a regular polygon. And we see that the size of each angle in a regular polygon is just the angle sum divided by how many sides there are. In other words, we do what we've done up here, and then we divide it by how many sides there are. So, let's have a look here. Well, first and foremost, before we do anything, the angle sum for this is, let's have a look, 1, 2, 3, 4, 5, 6, 7, 8. So it's got 8 sides, so the angle sum is 180, 8 minus 2, which is 180 times by 6, which is 3 lots of 360, that's 720. Oh. Do you know what just happened then? I had to pause because I had a brain freeze and I left my calculator on my desk. That's 1080 degrees. All right. And so if we want to figure out what's the size of each angle, well, we know in total it's going to add up to 1080. And now we have to divide it by 1, 2, 3, 4, 5, 6, 7, 8 angles. So the size of each angle, the angle size, is 1080 divided by 8, which, I'm just going to pause to figure that out, which equals 135 degrees. And so if we want to figure out each angle, we do the angle sum, and then we divide by each individual angle. But now we've got a bit of a strange one. Here we've got a 1, 2, 3, 4, 5, 6-sided shape, which is a hexagon. Oops, sorry, you can't see that yet. I beg your pardon. A 6-sided shape, which is a hexagon. And so what it's actually asking is two things. What's that? And as a consequence, what is that? And so, first, let's figure out what the angle sum is and then divide it by 6. So the angle sum is going to be 180 times by 6 minus 2, which is 180 times by 4, which is 720 degrees. And now the angle size is going to be 720 divided by 6, which equals, let's work that out, so that's 120 degrees. So therefore, M equals 120 degrees. Now, we get angle sum of a polygon. Remember, now because we're getting older, we have to write down what we used in order to be able to work it out. Should have written that on the top one. But now n degrees is what? What do we see here? We see that this is a straight line, therefore these two are the supplement of each other. And therefore, 180 minus 120 degrees, n has to equal 60 degrees. Here we have a third one. Can it truly get easier than this? Well, before we can, if this was a quadrilateral, we know it adds up to 360 degrees, but this is 1, 2, 3, 4, a 5-sided shape. So we know the angle sum for a 5-sided shape is 180, 5 minus 2, and we did this already in one of the earlier questions, which adds up to 540 degrees. So now, if I'm going to figure out y degrees, it's 540 for the whole thing, minus 3 lots, 90 degrees, minus 48 degrees, just work that out, and that equals 222 degrees. So we figured out the whole thing, and then we subtracted all the angles that were given to us. Now, last but not least, we have the sum of the exterior angles of a convex polygon is 360 degrees. And this is quite interesting, that if you add up all of the exterior angles, so if we project each side onwards, all of those exterior angles will add up to 360 for a convex polygon. And so, for a regular hexagon, find the size of each exterior angle and find the size of each interior angle. Now, we already established in the earlier questions that the angle sum of a hexagon, and we can work it out, but we already established that the angle sum of a hexagon adds up to 720 degrees. Therefore, each angle is 120 degrees. Therefore, each interior angle is 120 degrees, and therefore each interior angle is 120 degrees, and each exterior angle has to be 60 degrees. Now, but what's a different way of actually doing this? Well, if we know that that, and that, and that, and that, and that all add up to 360, we know there's 1, 2, 3, 4, 5, 6 of them. That's 360 degrees. Exterior angle is 360 degrees divided by 6, which is 60 degrees. And so that's another way of figuring it out. This is sort of a backwards way compared to what we've done before. Sorry for the clunky pause. Now, also excuse just the slightest bit of background noise. I'll speak loudly and to drown it out. But if we look at this situation where we've got each exterior angle is 12 degrees, we need to imagine that each angle on the outside is 12 degrees. How many would it take to add up to 360 degrees? So in this case, we do 360 degrees divided by 12. Please excuse my awful writing. and we see that it would take 30 exterior angles in order for 12 degrees to eventually add up to 360 degrees. And so this shape has 30 sides. Whereas what we want to do now is we want to figure out what's each interior angle. Each interior angle is 160 degrees. So this is a little bit cheeky. Sorry, the background noise is ridiculous now, but if we see that each exterior angle is 160 degrees, that means interior angle, the exterior angle is 20 degrees. That means now we have to do the same thing. Well, how many lots of 20 degrees add up to 360? And so it's 360 degrees divided by 20 degrees, and we see that is 15, 18, and therefore it has 18 sides. So we've just done polygons in one big hit. Sorry for the clunky edits. If you want to kind of stop and pause and look over things, please do so. But otherwise, let's get cranking. This topic hath ended.